Hello everyone, welcome to the video. In this video, I'm going to discuss about the introduction to the quantum computing. Nowadays, we are hearing a lot of buzz around quantum computing and its advantages and its superior features over the classical computers. First, we need to understand why we need quantum computers, how it differ as compared to the existing classical computers, why it perform faster, how it can solve the complex problems which is not possible by using the classical computers. Here I mentioned the classical computers is nothing but traditional computers what we are using nowadays, and the quantum computers is nothing but the computation process use the basic principles of the quantum mechanics with the help of mathematics, linear algebra, and computer science. As we know that today's computers are very, very powerful. By using the existing classical computers, we solve the many advanced technologies like artificial intelligence, space research, even climate predictions, robotics, communication systems, etc. Even modern computers, like a supercomputers, can perform millions of calculations per second. But still, several complex problems, the classical computers are not suitable, especially for the drug discovery point of view, cryptography, material simulations, optimization. Especially in these fields, the classical computers performance is very weak. It takes very huge time to process the information to give the results. Because the classical computers works in a sequence manner, one after another, not simultaneous. This is one of the disadvantage related to the classical computers, where we need the more computational process to execute the results. To overcome these drawbacks, quantum mechanics gives a hope because of its several added features as compared to the classical computers. By using the quantum algorithms or the quantum mechanics, it gives the additional hope to the process of execution of the results for a particular complex situations in a much faster manner as compared to the existing classical thing. So how the quantum computation or the quantum computing can process the information in a much faster way as compared to the classical thing is because of its added features like superposition, interference, and entanglement. I'm repeating the same. The added features for the quantum computing as compared to the classical computers like superposition, interference, and entanglement. We need to discuss about the how these three, that is superposition, interference, entanglement, use the added advantage to the quantum computing which is not possible for the classical computers point of view. First thing, the information is stored and processed in the form of qubits in quantum computing, whereas in case of classical computers we use the general bits like 0 and 1. We generally use to represent 0 as the off, 1 as the on. In case of classical computer point of view, every stage we need to check one state after the other, but not simultaneous. But whereas in case of qubit point of view, it may be available in the 0 state or 1 state or simultaneously both. You may have a doubt how it is possible. For example, if I take the qubit relate to the particular position. Then I represent it as psi. It can be available in the both states of 0 and 1. Then we have a doubt related to the what is the possibility of getting state 0 and what is the possibility of getting state 1 or state 0. Here in this particular superposition, we use to represent it as the probability like alpha state 0 plus beta state 1. Here the alpha and beta are the probability amplitudes, and the condition is alpha square plus beta square must be equivalent to 1. So it is completely works based on the probability features. For example, if the state 0 is having 100% probability, then beta is 0. If the state 1 is having the 100% probability, then state 0 probability is 0. So that is nothing but the combination of both the states, and it works based on the probabilities function. If when we are taking as the 1 qubit, it exists in the two states, either 0 state and the 1 state, like a simultaneous way. If we are considered it as the 2 qubits, then 4 states 0 0 0 1 1 0 1 1, and it is represented like alpha of state 0 0, beta of 0 1 state, gamma of 1 0 state, and delta of 1 1 state. Because in case of 2 qubits and we have 4 states, the superposition is the combination of all states. Alpha, beta, gamma, delta are the probability amplitudes related to the 0 0 1 0 0 1 and 1 1 states respectively. Because of this kind of superposition, here the superposition is nothing but all the states exist simultaneously. Because of this, in case of computation process, it checks all the states simultaneously without like a sequence manner, one after another. It takes all the states simultaneously, and it check based on the probabilities values. So simultaneous checking is called as superposition, and interference is nothing but, as we know, the constructive interference, destructive interference, constructive point of view, sum of amplitudes, and destructive interference point of view, like a subtraction of amplitude, resultant amplitude is subtraction. Similar way, in case of like a computation process in quantum computing, first it takes the system is like a superposition, all states simultaneously. And then, for example, I just take it as like a 2 qubits, we have 4 states, and the probabilities is like alpha, beta, gamma, delta. Out of these 4 states, we need to check which state is having the better possibility, like a positive result, and which is like a ruled out like a negative probability. Negative means like a less possibility of getting results, or positive. For example, positive amplitudes like alpha, beta, gamma is the getting hope related to the positive result, and delta is the negative result. So delta is ruled out, and this probability is added to the alpha, beta, gamma. So the positive, like a favorable probabilities are summing up. Unfavorable is like a removing from that list. This possibility is called as interference. So because of the interference and the superposition, finally the result is very, very fast because of simultaneous check of all the possibilities, and then adding of probabilities for the favorables, and deleting of the favorables, deleting of the states related to the unfavorable states. So this is one of the added advantage related to the quantum computing, which is not possible in case of classical computers. And third one, entanglement. It is mostly used for the like a quantum what it called as teleportation, quantum communication, because entanglement is nothing but the link between the one qubit with the another qubit. For example, these 2 qubits are strongly connected here. For example, 1 qubit is operated by me, 1 qubit is like a thousands of kilometer in the other location. Whatever the changes happen here, for example, I'm getting the result related to the 0 0 is 0, the same is happen in the other qubit. So based on that, the one particle state is linked with the other qubit state. So whatever the changes happen here, the same is happened to there without transportation of the particle from location to the another location. This is one of the added feature related to the uh, quantum teleportation or the quantum communication point of view. So in this way, the three added features for the quantum computing like entanglement, superposition and interference is giving the better possible results, especially for the different complex situations where the classical computers are not able to perform in a better way. So obviously the quantum computing gives a hope to solve the complex situations much easier as compared to the classical computers. The summary related to this: the quantum computers is use the basic principles related to the quantum mechanics, mathematical linear algebra and the computer science. Here it store or process the information in the form of qubits. The features like superposition, like simultaneous checking of all the states, and then interference, it giving like a probability sum up for the favorables, probability minus for the unfavorables ones, and entanglement, the link between the one state of qubit with respect to the another qubit state. Whatever the changes happen in the one state of that particular qubit is obviously changes the other state qubit. This is the added features for the quantum computation as compared to the classical computers. Right. Thank you.